Alright, so again, today we are graphing rational functions. You guys are going to use properties of rational functions to graph. Okay? So every day we're doing our problem of the day and our going over homework problems, all that is going to be applied here. Okay? So again, to help you out, you're going to build your burger. You guys should be building it now. Okay? We're going to start at the top, simplify if possible. Now, of course, if it asks you to find the domain and range, you do that before you ever simplify. Okay? Treat that like the fries. Okay? I don't know if y'all like me, when you get your food from McDonald's or Wendy's or wherever, you always take a fry before you actually get to your burger, don't you? Yeah. So then there you go. That's your domain. Right there. That fry is your domain. Then you simplify if possible. Okay, I don't know about you, but places mess up my order, so I like to check my burger, make sure everything is there. Find the holes if necessary. Okay? But if there are any. Then plot your x and y intercepts. Remember, how do you find your x-intercept?
You set the numerator equal to 0.
Set the numerator equal to 0. How do you find your y-intercept?
Plug 0 into x's.
Plug 0 in for x. Then find your vertical asymptote. You set your denominator equal to 0. Then you find and sketch your other asymptote. So it's either going to be horizontal or it's going to be slant. That's when you do that there. Then find any points in between if necessary. Sometimes your x and y intercepts are enough points that you need to graph this rational function. And then, of course, draw your smooth curves to connect it all to one juicy burger. Yes. Okay?
Yeah.
So, I do apologize if any of y'all did not eat lunch. Here we go. Here's our first example. We are going to graph x plus 4 divided by x minus 3. We're going to graph that. We're going to start off simple. So trim up your pink grids. I suggest you putting this one along the side of your burger so you can have an example right there by your burger. And we are going to graph this. Yes, sir. So, let's find the domain. It's always good practice. You do that before you ever simplify. That's that fry you reach into the bag to get before you open up your burger. Okay? What's the domain of this function?
3.
3?
X cannot equal 3. X cannot. I knew that.
X cannot equal 3. It's wherever the denominator is equal to 0. Okay? So there's your domain there. So now there's that fry. We got our nice little fill there. Now let's go into this burger. Can we simplify this? Can anything factor? Can anything cancel out? No, and no, you cannot cross out those X's, okay? Every time you do that, okay, you're killing a kitten or something, okay? Don't do it. Don't do it. That's all I mean. So every time you do that, you kill a kitten. That's horrible. The whole thing, you think of that image every time you do that.
Wait, is it a cute kitten?
It was a cute kitten. All right? So now, simplify if possible. Now let's find the holes, okay? Do we have any holes? No. If nothing simplifies to where something cancels out, then that means there are no holes. Okay? So no holes here. What's the next part of the burger?
X and Y intercept.
X and Y intercepts. And you find again your x-intercept by doing what?
Top equal to 0.
Setting the top equal to 0. So that means our x-intercept is going to be where?
Negative 4, 0.
-4, 0. -4, 0. Okay? Now we have to find our y-intercept.
Wait, that's your x-intercept?
-4, 0. Now let's find our y-intercept. You do that by doing what? Plugging in 0. So
0. 4 over -3.
4 over -3, so this is -4/3, right?
Yes.
There's your y-intercept. Question.
So say your x-intercept has 4 or something like that.
Mm-hmm.
Never mind. Yes, I just kind of figured out my head.
Questions up to here. Alright, what's the next part of your burger?
Vertical asymptote.
And you get your vertical asymptotes by what? Setting the bottom.
Equal to 0.
So that means our vertical asymptote is going to be x equals 3. is a vertical line going through the x-axis at a positive 3. All asymptotes are drawn with dotted lines, and there it is. There is x equals 3. Are you guys seeing how we're using the same information we took last week to develop this graph?
Yes.
Good. Now what's the next part? And what's the pattern, right?
No, we just did that. Find and sketch other asymptotes.
So do we have a horizontal asymptote or do we have an oblique one?
Horizontal.
Look at the degree. What's the degree of the numerator? 1. The denominator? 1. So because they're equal, you look at the coefficients.
1.
So it's going to be y equals 1. Not 0. There's always an imaginary 1 in front. So 1 over 1, which makes 1. So that is a horizontal line that crosses the y-axis at 1. Is everybody still with me? Okay. Now, the second to last step says to find any points in between the asymptotes if necessary before you draw your smooth curve. Clearly, remember, all rational functions are going to, like your most basic one looks like this. You guys remember this?
Yes.
From your parent function, correct?
Yes.
Okay. So, the x and y intercepts are 2 points that are on one of those branches, on one of those curves. So you can kind of already see that one of the curves is going to go through those intercepts, get really close to the asymptote, but never cross or touch. Can everybody see that? But it's not just one branch, it's going to be 2 branches. Where's the other one going to be there?
Now, where? Right. Up
Top.
Up top. Same side. Over there, maybe.
To the right. If you're unsure of where it needs to go, that's when you do that second to last step. Pick a point. We kind of already know, everything to the left of that vertical asymptote. Let's plug in a point that's to the right of it. What's the point that's to the right of that asymptote? 4. If I plug in 4 for x, plug it back into the original. What's 4 plus 4? 8. What's 4 minus 3? So 4, 8 is where another point lies on your rational function. 4, 8 is somewhere up here. So that pretty much lets us know that the other branch is in that section right there. Questions on how this graph was developed? You find all the goods, all the properties, and then you just pretty much put it on a graph and connect it with a smooth curve. Go ahead and get this into your graph, your picture, glue it in, and get ready for the next one. Alright, so for this next one, 6 over x plus 3. I want you guys now to find all the goods. Find the domain, find the x and y intercepts, find the vertical asymptotes, find the horizontal or oblique ones. Do all of that. I'm going to give you 4 minutes to do that, and then we're going to come together and put it all together in a graph. All right, so domain, let's see. Relation. It's done. So the denominator equals 0 and find out that x can be everything but -3. Awesome. Do we have any holes, Brian?
No, because it does not simplify.
Exactly. No holes. It does not simplify. Michaela, give me something. Anything. It's what? 0, 2? If you plug in 0 for x, so 6 over 3 is 0, 2. Very awesome. Okay. Let's see. Christian, give me something else. There would not be any. Exactly. So when you take that top and you set it equal to 0, that's not possible. Okay, so there are no x-intercepts. Good. All right. Isan, give me something else.
The y-intercept is written.
Yep, that y-intercept already. Negative 3. So the denominator equal to 0. It is negative 3, but remember, it is an asymptote. It's an equation, so it's x equals negative 3. X equals negative 3. Okay? Horizontal asymptote. Okay? Horizontal. Savannah. Y equals 0. Good. The denominator is bigger than the numerator. There's nothing there. So it's like an automatic 0. So the denominator is bigger, so it's y equals 0. And what else? Additional points. Okay, can we kind of see where one branch is?
Yes.
It's going to be in the top right, correct?
Yeah.
Where's my other branch? It's going to be on the left side, top or bottom? It's going to be on the bottom. Let's double check that. Let's plug in negative 4 for x. When we plug in negative 4 for x, what's the y value going to be? 6 over negative 1, so negative 6. So yes, it confirms that when x is negative 4, y is negative 6. So approaching the asymptotes, there you go. Yes. Oblique. I think the next one's an oblique one.
Yeah.
Okay? Real quick, this is always a good time to loop. The limit as x approaches infinity is what? Say again. 0. The end behavior as x approaches positive infinity is getting closer and closer to 0. What about the limit as x approaches negative infinity?
0.
I am recording. Ready for the next one? Alright, here's the next one. X squared minus 9 over x minus 1. Find all the information and we'll come back together. What's the domain? X is the element of all real numbers. Cool. Any holes? No holes. Even though the top does factor, nothing cancels out with the denominator. Okay? X intercepts. Yes, you can have 2. You can actually have 3. Okay? You can't have none. What are your X intercepts? 3, 0. Negative 3, 0. You set the top equal to 0. What is the Y intercept? 0, 9. So 0, 9 is all the way up here somewhere. Yes, I can change the scale, but I'm not going to do that for this. And then negative 3, 3, and negative 3, 0, and 3, 0. Vertical asymptotes, do I have any? What is it? X equals 1. Do I have a horizontal one?
Yes.
That's not horizontal, it's actually slant, oblique. It is y equals what? X plus 1. You get that by doing the opposite and then putting in the coefficients. Don't forget that placeholder. 1, 1, 1. That negative 8 we're not concerned with, only the coefficients. Now, x plus 1, that's the line with the slope of 1 and it crosses the y-axis at and 1. So you go up 1, over 1, up 1, over 1. That's how you plot the oblique ones, going old school, algebra 1. Okay? Now you can see from this where the asymptotes are and where the x-intercepts are and where the y-intercept is. You can kind of see where the two curves should be, correct? Question.
If the oblique thing is
x is y equals x plus 1.
Now, let me say that then you should go right plus 1.
No, it goes up 1.
Oh, up. Oh, I see now. Never mind.
Now the curves you connect through your y-intercept and through your x-intercept here. Does everybody see that?
Excuse me, Ms. Anderson?
Yes. And the other one's going to go through the other x-intercept. Right there. Goes to the vertical asymptote, not crossing or touching. That's how you draw a rational function with a oblique asymptote. Yes. Plugging in 0 for x. So it'll be 0 minus 9 over 0 minus 1. So then it'll be 9. Other questions on these? Yes?
For if you got it across one,
A cross at,
across the y,
yes, because of the equation is in y equals mx plus b4, and b is the y-intercept, yes. Other questions on this?